Physicists often talk about the world as consisting of fields, for example, the magnetic field. But what the heck does it actually mean? I mean, the word field sounds like a field of dreams, a battlefield, a baseball field. But fields are one of the most important concepts in physics. You can think of a field as a kind of fluid that fills space. The analogy is not perfect. A fluid has many properties that a field lacks. A field doesn't consist of smaller particles. A field doesn't move. But the analogy to a fluid does capture the idea of a continuous thing that fills space. There are lots of different fields all commingling with one another. The magnetic field, the electric field, the gravitational field. There are also less familiar kinds of fields, the electron field, the Higgs field. In fact, every type of elementary particle has its own field. Fields can ripple like the surface of a pond, and that's how forces get transmitted. In fact, a particle can be thought of as the smallest possible ripple in a field. Particles can be created and destroyed. They either arise from or settle back down into their field. Physicists represent fields using numbers. Each and every point in space has one or more numbers. And fields come in different types depending on how many numbers they require. The Higgs field is a scalar field. It just takes one number at every point in space to describe it, sort of like a map of temperatures. The electric and magnetic fields are called vector fields. They have both a number and a direction at every point in space, sort of like a map of wind velocity. The gravitational field, according to Newton, is also a vector field, but according to Einstein, it's a more complicated kind of field called a tensor field, with a whole grid of numbers at every point in space. Those numbers represent how space and time are distorted. Although the concept of fields is at the root of today's physics, it does have its problems. Quantum physics changes our ideas of what a field should be in a way we're still trying to figure out. It may turn out that fields are just an approximation to a deeper level of reality.